Hello everyone. In this video, I'm going to explain single responsibility principle. Even though it is a simple one to understand, it is very hard to practice in real life. Let's see what the principle states. As per single responsibility principle, a class or module should have only one responsibility. It should change only for a single reason. Let us look at an example to understand this principle better. Um, you join a new project, for example, that helps a milkman in daily milk delivery. The software collects the order from each house and the milkman delivers the order each day. This is the project that you are going to join. Now you are asked to implement two features. So the features are, so we are going to allow the customer to order custom quantity of milk. So something like 500 ml, 1000 ml and 2200 ml, things like that. And we would like to deliver the order if half of the cost is available in the wallet and mark the remaining as debt. That's a good gesture. So sometimes if the wallet runs out of money, then we say we will still deliver the order and then maintain some debt and then correct this later. You may be wondering what are these requirements, how to implement them, and how to implement in a very good fashion. In real life, if you see, most of the times you'll be working on a project which is already running. There is an existing code base. Somebody has designed some parts of it, and then you are asked to implement a new feature or you are asked to fix a bug, and you should ensure that you do this new feature or bug fix in a very clean fashion. Again, this is very easy to say but very hard to realize in real life. So let's jump into code and see. Basically, if you see the program is a small one, so we have roughly some 60 lines of code. Okay, but even this 60 lines of code can be complicated if it is not what's say written in a proper fashion. So if you look into this class, so the class is called a milkman. So if you look into the requirements, it is a software that helps milkman in delivery, right? So they have named the class as milkman. Looks fine. Then we have various list of orders. So we see cow milk, goat milk, camel milk. Then there are some chocolate, biscuit. So these are all the different orders. Then we have some information regarding wallet balances, how much money the customer has prepaid. Then we have some information regarding price, like what is the various items price, and then we have one method which is like a guard method which takes all this information as a function parameter and then copies them internally to our internal data structures. Then comes our important function which is to deliver the milk. So basically if you see, the milkman takes each order, calculates the price for this order, then checks whether enough money is available in the wallet. If enough money is available, he makes the delivery here. See, first he delivers the milk order, then he delivers chocolate biscuits and other orders actually. If not, he then skips the delivery altogether. And you can see this is a small test run where we create the milkman, we provide the order information, and then we deliver the milk. If you see .NET run, well, so you can see yes, house 0 it made the delivery, house 2 delivery was made, house 1 I think not enough cash is available, so we skipped the delivery. This looks to be okay. But now when you have to implement this debt logic and also custom things, basically what you can do is you can go in the same uh, direction how they have implemented. So for each of these custom packet sizes like 500 ml, 200 ml and 1000 ml, you create separate list, you add those parameters here, and then for the debt logic you change this information here where if the price is half of the price is available in wallet, then you do the debt calculation and then you complete the fix. So this is one way to do. But if you go in this fashion over time, this class will become completely unmaintainable because there are too many responsibilities that this single class is handling as of now. But before we jump into refactoring this class into something meaningful, let us also see why we ended up in such a case. So let me go back to the first ever version. So this is the first ever version of the software that was released. So if you look into this, so now let us look into the requirements. So the requirement says we would like to help our milkman in delivery. Straightforward requirement. Then we have step 1, that means the requirement number 1 is each house in the street provides the number of milk packs needed. Our milkman in the morning delivers the order to each house. If you look into the program now, you can see the milkman class is written. There is a list of milk order. The milk order is taken in from outside, and then the milkman takes the order list, looks at the order from each house, and then makes a delivery. This was the initial version which was there. Basically, if you see, this class doesn't violate single responsibility principle in any way. It is clean, neat, and then does everything needed. Now let us go to version 2. Now if you look into version 2, they added one more requirement now, that we are delivering 3 different types of milk. So they say we are going to deliver cow milk, goat milk, and soya milk, and houses can choose the milk type. Now if you look into the program to implement this requirement, the developer brought in a milk type. He changed the milkman class to also take the milk type for the order, and then now there are 2 lists which is given. One is the milk count and another one is the milk type. Again, if you see, the milkman delivery logic is simple. He goes into the milk order list, looks at them one by one, and then makes the delivery. Again, there's no violation of single responsibility principle here. All looks fine, and you can see in the dry run also we have very simple application as of now. Let's go to iteration 3 now. What happened? So in iteration 3, they say a house can order a combination of milk daily. So they say until now they can choose between either one, but now they can also choose between cow, goat, and soya milk. Okay. So what we do, if we go and look into the source code, so we remove the milk type now because we know only 3 types of milk we deliver. So we created instead 3 lists. So cow milk order list, goat milk, and then soya milk. So for each order we have a list. Then we take this information in our set order list, and delivery milk still does the same thing. It looks at the order one by one, and then whatever combination they have ordered, so the same combination of milk is delivered. Again, this looks to be fine. There's no violation of single responsibility principle now. Let us go to step 4. In step 4, they say we added a new milk variety called camel milk, and then they are saying we are discontinuing the vegan milk now, and also we are expanding our business and would like to deliver chocolate and biscuit orders for the with the milk actually. So now if you look into the class, you can see in addition to the milk, so we remove the soya milk, we change it to camel milk now. We also take 2 more lists, which is for the chocolate and biscuits now. And this method is slowly growing, and you can see now there are 5 lists that is being taken into this order information. And in the order now we have 1 row which does the milk delivery, and then 1 row which does the biscuit and chocolate delivery. But we still call this class as milkman because the primary responsibility is milk delivery. Okay, so this is done. So now let us go to the next iteration. This is where we stood. So now what we say in step 5, they brought in a requirement saying we are switching to a prepaid model now. Before delivery, the milkman checks whether there is enough money available in the customer wallet. If balance is less, then no delivery is made. So now what we see, we also want to maintain the prepaid balance information. So we add one wallet balances here. We also need to calculate the price for every day. So we also bring the price information into this class. So we need the price information, and then we take this information from outside. That means we take the wallet information also as a part of our order. And then in the delivery milk, now what we do, we calculate the price. That means for each order, what is the price? And then we check if there is enough money in the balance. Then we make the delivery, adjust the balance in the wallet. If not, then we say not enough cash to buy the order, and then we stop here. So if you see, now the class came to the state where we started. Basically from the initial version, we came here one step at a time, and then there was only one list, then we added one more list, then we added one more list, then we added two more lists, then we added one more list, and then there was a price information, so we added this price information here. Then we thought each time we added one parameter. It is not like we day one we created a set order and we put all these things in. Then we looked into the deliver milk, and then we saw that we also need to do this prepaid logic, so we implemented the prepaid logic also here now. And finally what we did, this dry run also has been changed to accommodate all these changes now. So basically this is how the whole complexity comes in. So it is not like we write the complex code on day one. Each time a small delta amount of complexity comes in, which we can still consume. So we bring that complexity into our code, and then we add this to this code complexity. But over time what happens, if a new person comes, for them it may look completely out of place, and then it becomes really hard to maintain such code base. So there comes a time when you decide that I have to refactor things and do some changes. So now if you see, this code looks quite hard. There's a guard method, why we have wallet here, why milkman is delivering biscuits, why price info here. There are like this, there are so many questions that comes to a new developer who joins this project. So before we jump into code and then implement these two new features, we refactor this code into something manageable. If you look in currently the responsibilities, this class has responsibilities for delivery, it has responsibilities regarding price, it has responsibilities to maintain order, it has responsibilities regarding wallet. All these informal responsibilities are there together in one single class. So what we do, we try to refactor them into separate entities. So price is a separate one, wallet is a separate one, order is a separate one, and delivery is a separate one. Let us see how this can be done in the code. Now let me check out. Let me open the old code actually. So if you look, this is the code that we were having in previous iteration. So basically first what we look and see is there is a lot of information regarding order. So let us refactor this order into a separate class. So what we do, we create a class called order. And if you see, whenever we do refactoring, we create each class in its own separate file. The reason is we don't have much distraction. The order file only talks about order, and other things we don't get to see in this class. So an order has two information, the item and the quantity. It maintains a dictionary for that. And For an order, if you give the price list, it can calculate and return the price. And also when you want to print an order, it provides a utility method toString, which can print this order in a nice fashion. Next, if you see, we have some wallet balances, which is customer wallet and wallet related information. So let us carve this out into a separate class called wallet. So in the wallet, we have two information: what is the current balance and what is the debt. So initially some amount is provided to start with, and whenever the customer adds money into the wallet, we adjust the current balance, and also if there is a debt, then we adjust the debt also, and then ensure that the balance is always reflecting the current amount. And whenever you need to take some payment, for example from this wallet, the if the balance is fine with respect to the order, then we just do the calculation that it's okay. If for example the balance is less, then we do this debt logic here. What we tend to do, we say if there is half the amount is available in the wallet, then we try to still allow the payment to go through. If not, then we say okay, the wallet doesn't allow you, there's no enough money, and then the payment fails. Now if you look into the third thing, we have some information regarding the price. So we can see various price is maintained here. So we try to carve this out into a separate file and a class called price list. And price list, normally we would load this information from some kind of a database, but here for the sake of simplicity, I'm loading it here in the class itself, hardcoding. If you see, we create a dictionary for each of the item. We have the price listed here, and if you give an item name, then it can find the price for that item and it will return the price. So this class takes care of all the price list related information. Now let us see how Milkman looks now. So from here, the same Milkman class is refactored into a Milkman here. So we have a list of order, we have some price list, and we have some wallet balances. So the Milkman takes all this information every day. That means what is the current order, what is the current price list, and what is the wallet information of the customer. Then when the milk delivery should happen, basically he takes each order, he calculates the price, and then he checks whether he can get the payment for the price or not. If he can get the payment, then he says he makes the delivery. If not, then he says not enough cash to buy the order, and then he skips the delivery. So this class looks much more clean and easy to understand. And also now whenever a new logic has to be implemented, for example when you have to implement these different quantities of milk, all that you need to do is you have to go to price list, add these new quantities here, for example cow milk underscore 200 ml, and then put a price, and order anyway will take care of generic item now. So there is no individual list anymore, so it can take any mixed order now. And the Milkman class looks much simple and clear, and there is only one responsibility, which is still order delivery. But taking all this information, if you see, each of the respective other responsibilities are moved to the respective classes. And finally, if you look at the program, you can see we have a list of order, then we have a list of wallet info, we create a price list, and then we just say deliver milk, and this code looks much more clean and neat. So basically we started from a monolithic class, and then slowly we refactored into individual responsibilities. Now once you have things like this, again you will start to get new requirements, and then you will implement requirements one by one in each of these classes. Again over time they'll become complex, and then you have to redo the same refactoring and ensure that the responsibilities are clearly separated. That way it will be easy for you to develop and implement new features, and also keep the complexity under check. Thanks for the time, and see you in some other video later.